And this is the libhal biweekly meeting. This is going to be a short one today, only a few items for this week, but spent quite a bit of time looking into this and working on this. So the first item is going to be trimming library names was a mistake. I'm going to be explaining why what I talked about last 2 weeks was actually a mistake in our design, and I reverted it. And I'm going to go over the new automated template repos, libhal target and libhal device. Now let's discuss why trimming the library names was a mistake. So last week, the idea was take libhal LPC or libhal LPC 40XX to represent the LPC or NXP's LPC 40 series of microcontrollers. And I was thinking, well, there's some common code between 17XX because they're actually pin compatible, and most of the IP blocks are about the same, meaning the peripherals, the actual devices and stuff like that, all act and operate around the same way. So I thought, well, if they're going to be somewhat similar to each other, might as well just group them all together. They're all part of LPC, right? It shouldn't be an issue. Same thing with STM. I was like, well, I could throw all the STM32 stuff into one big old, package. But so why did I revert? Well, when I was working on combining STM32F1 and STM32F4, et cetera, and all the other ones in there, under one common version, I realized that any breaking change to STM32F4 looks like a breaking change everywhere in the package. And now the version has less predictive power. Now when you break something or even just change a feature, you don't know which particular part of the library got changed. And when I noticed that, I was like, oh yeah, it would be nice if you could know if you are using libhal STM32 or STM and know that a breaking change has anything to do with you. Like if you're using STM32F1, the breaking change probably has something to do with you if you're specifically targeting that particular device. But if you're only using STM-F1 as your target processor, the thing that you're going to write programs for, but something breaks somewhere else, but some additional new features get added in on your particular core, now you have to figure out whether or not the breaking change really did break you or if it did not actually break you. And there could be a break that, yeah, you just get an API break, usually you can just upgrade and then check to see if your code compiles. But again, it's one of those things where if you have a major change that is breaking and also causes some other issues, that could just be really annoying. So that's when I realized that it's better to just simply go back to what we had before. Each family of drivers has its own repo. I also removed the XX and stuff like that, just the X's from different repos, just because I felt that it just added more text, didn't really add any information. And I think what we should do is just kind of go with the first letters that are common, the set of letter numbers that are common, and then whatever else comes after that, so long as that's all within the family, that all gets added in. If there is separations between the families, then it's probably multiple families, in which case you want to split those up anyway. Next up, we have the new automated template repos. I'm really excited about these because they are going to make our lives a little easier. So there's now libhal __ target __. Same thing with device with the underscores. They are repo templates that automatically rename files and file contents that have the __ target __ or the like with the name of the repo based on this pattern, libhal-package name. Let me show you an example. So if we go on over here, we can see STM32F4, which was generated through libhal-target. So I'm going to go over here. You can see that all these different files are pretty much updated and create and control or updated through the create pull request automated change. And yeah, so I'm actually just going to go here real quick. I'll go to libhal-target. You can see that the original has -- target _ everywhere. And what I'm going to do is I'm going to make another repo. Now I'm trying to think of a good repo to make, and I did not plan for one before I got here. So I'm just going to move this over to libhal. All right, and what would I do? Should have thought about this before I got started. Is there anything I haven't added in yet? I know. libhal-samd20. Yes, I've not made a repo for that one yet. And I don't know what to call it, so I'm just going to call it, description I meant to say. Let's go to description. Let's go to repos. Let's go to, actually, it's not a good one. I'll just go back to, we'll take the SAMD21 one. Copy and paste that here for the description. Make that 20 now. Make this public. and go for it. All right, so now it's generating the repo. Give it a little time. While it's doing this, a couple things we have to do. Okay, so it's done doing this part. We can see that some continuous integration steps are running. The checks are running right now, but they're going to fail. They should fail. I'll go back to that in a sec. If you go to settings, I can go over to pages. I'm going to set the deployment for the web pages to be from GitHub Actions and not from a branch. This is such that the GitHub Actions can actually deploy things. Without doing that, the deployment will always fail. And look at that. So now we have a pull request made out of nowhere. So this comes from the action, once it loads up, update package name. And what it does is, once it load here, installs the rename program, updates the repo names. Well, this goes through all. This actually stores and grabs from the repo name, the actual target, the portion after the dash. This then replaces everything within the files, ignoring the .git file. Then it goes through and replaces all the directory names using the rename function. Then it goes and renames all. So it renames all the directories first, and then renames all the files. If you do them together, if it renames the folder and then it tries to rename the file, but the file's original path was the previous path, it'll say it doesn't exist, and that's not correct. So what we want to do is do the directories first and then do the files that are within there. So we do a new sweep of everything else from there. Then we update this information inside the YAML file, we remove the update name YAML file. This is what allows this particular change to be a one-shot. It only runs once because after you run it, it'll create a pull request, which is the step right here, after it's removed itself. So you go over to the pull request. If you look over at the files changed, you can see all the underscore target. You can switch it over to SAMD20 all throughout this area here. You can see it happening here as well. Some dummy, placeholder components are also put in here as well. Everything you would need to just get started is all basically supplied. And if you find something else that you feel should be in the original target template library, bring it up to me, put it on discussions, because I think that'd be fantastic for us to add if there's anything that you feel like we were missing. So from here, go over. I'm going to approve it, and then I'm going to go over to now. I'm going to add a protection rule here. If you're doing this yourself, you may not be able to do this if you don't have the rights for libhal, but if you don't, it's fine. You can just merge this in if you have merging privileges. Here I'm just going to add in the rule. My current rule is just to require a pull request before merging anything, and then also require status checks, and then press create. And then, I'm going to skip this step. Let's not go there. So for now, it's not important. Right here, I can just press merge pull request, merge that in, and it's changed. Delete that branch because we don't need it anymore. And now we have libhal SAMD20, linker scripts for SAMD20. These are just, dummy, placeholder stuff. You can change these up to whatever fits your needs. What you can actually do is look for the word or the phrase to do, parentheses, libhal-target. That basically tells you to look through. Actually, let's see if I can do that here. Yes. Every time we find it, is being indexed right now. Try in a few minutes. Okay, so the repo is still being indexed, so we can't actually search through it at the moment. But if we could, we would find a whole bunch of locations where we'd see to do libhal target. For example, if we go over to conan.file.py, we scroll down to the bottom here, and you can see a little to do here to add the appropriate components for your particular target, as well as also to do here to add in the appropriate architectural flags. Like, is it a Cortex M3, M0, M0 Plus, M1, M7, whatever. And then what type of floating point, if it uses floating point arithmetic or if it has to emulate it through software. And there's a little bit more work to do, but that's pretty much it. Once you have these things set up and then you've added all of your linker scripts, you have done what I consider like the lowest level and beginning steps for board bring up. Because you can, once you have this stuff set up, basically write a binary and then actually flash that to the device and run it. Now, it won't be able to do much of anything. You won't be able to blink an LED because there's probably no LED driver yet. We haven't written that. The output pin driver here is pretty much empty. You have to fill that part out. the first demo that's placed into the demos folder is blinker.cpp, which uses right now the inert output pin, but what you want to do is replace it with your SAMD20 output pin. So that's where another to-do comes in, is to swap that out and also make sure that this is actually set to the appropriate frequency so you can get it to blink at this particular cadence. So yeah, the libhal underscore device, same thing. Just this one doesn't have linker scripts. It doesn't have components because it's not usually necessary for device libraries to have that. If they do, well, probably not linker scripts, but if they do need more components, that's something that could totally be added in. But it's not something that's usually immediately necessary. Therefore, we don't concern ourselves with it. So yeah, that's pretty much it for this week. I just wanted to show you that because I think that this automated process will make our lives a lot easier. It removes a lot of the effort on our part, on my part, on anyone else who's going to do board bring up, and then kind of allows you to focus strictly on what's important, which is adding in the details that may not always be the most obvious or simplest or easiest to go and find. Or they may be easy to find, but they're not automatable. Everything else here, though, is automatable. So we made sure we automated it. And yeah, that's pretty much it for the video.